Assalamualaikum warahmatullahi wabarakatuh. Welcome to more example related to finding the area when you have one function on the graph. So the first question here is, what's the area bounded by this curve? And x is equal to -2 and x is equal to 1. So we're going to sketch the curve of y is equal to x cubed, and this is how it's going to look like. So this is x, this is y. So y is equal to x cubed will be something like this. Okay, so this is y is equal to x cubed. And next we are going to find the boundary. So the boundary is x is equal to -2. It could have been somewhere here. So we have a line here, x is equal to -2. Next we have x is equal to 1, could have been somewhere here. So this is x is equal to 1, and therefore the area that you are looking for is this area bounded by the curve. Okay, and this area. So we have the curve that is part of it lies below the x-axis, and another part is lies above the x-axis. Okay, so we know that this area here is going to be negative. We need to do something to make sure that it becomes positive, and this area here is going to be positive. Okay, all right, so next, now there are two parts of integral that we need to consider. The first part is from -2 to 0. So this is the first part, from -2 to 0, and I have actually explained this before in the previous video. We need to introduce a negative sign outside this function in order to make sure the area here is going to be positive when you integrate that. So we have -x cubed dx plus another part of integral is from 0 to 1, 0 to 1, so 0 to 1, and here we just maintain the curve, which is x cubed dx. Okay, so next, negative can be taken outside, so we have 0, -2, x cubed dx plus this one. If you integrate, you get x to the power of 4, 1 and 0. Okay, and this becomes negative x to the power of 4 over 4, 0 and -2. Okay, plus this one, you evaluate it, it will be 1. Substitute into this, you will get 1 over 4 minus 0 over 4. Next, this one negative, so 0 to the power of 4 is going to become 0, minus -2 to the power of 4 is going to be equal to 16. 16 over 4 is 4, plus 1 over 4, and next this becomes +4 plus 1 over 4. So next this becomes this is 16 over 4 plus 1 is 17 over 4. Okay, so the area is equal to 17 over 4. Okay, next we are going to find the area of a region bounded by the curve, this curve, the y-axis, and the lines y equals to 1 and y equals to 5. So let us start by sketching the area. So if this is the axis, so this is x and this is y, so y is equal to square root of x minus 1. So I hope you do remember, if you have y is equal to square root of x, the graph will be looking like this, something like this. So if you have -1, that means the graph will be shifted 1 unit to the right, and therefore the graph will be looking like this. Okay, something like this. So this is y is equal to square root of x minus 1. Next, we are going to consider the boundary. The boundary is given by y-axis, which is this one. This is the boundary. And then we have the lines y is equal to 1. It could have been this point. So y is equal to 1 is this line. Okay, y is equal to 1. Okay, and then we have y is equal to 5, so 5 maybe somewhere here. Okay, so maybe somewhere here, so we have another line. Okay, let me just extend the curve a bit. Okay, you get the idea, I hope. So the curve is like this, something like this. This is the curve, and so we are actually looking for the area, which is given by this area here. So this is the area, and I hope you can see that it is easier to consider integrating the curve here. It is easier to consider integrate this curve with respect to y, because then we have this boundary clearly defined, y from 1 until y from 5 to 5. Okay, so the limit here is y equals to 1 until y equals to 5. Okay, so we are looking for this area. Again, we are looking for this area, and therefore it is easier to integrate with respect to dy. Okay, we know that it's easier to integrate with respect to dy instead of dx, and the limit for y is between y1 and 5. Now what we need to do is we need to re-express this in terms of x as a subject. So we are going to let x becomes the subject. This is what it means by this case 4, which you have seen on this slide here. You re-express the given function from y equals to fx. So here y becomes the subject, and you have to change it to x becomes the subject, so then you can integrate it with respect to y. Okay, so okay, we go back to the example here. Okay, so for this one we need to convert y square root of x minus 1, so x has to become the subject. Therefore we know that this becomes y squared is equal to x minus 1, and therefore x is equal to y squared plus 1. So we are going to use this function, so I'm going to replace that into here, so that becomes y squared plus 1 dy, the limit of y from 1 to 5. So next we are going to integrate that. We get y over 3 y cube over 3 plus y, the limit is from 5 and 1, and this becomes 5 to the power of 3 over 3 plus 5 minus 1 over 3 plus 1, and this becomes 5 to the power of 3 is 1 to 5 over 3 plus, this is 15 over 3 minus 1 over 3 plus this is 3 over 3. So 1 to 5 plus 5 is 140 over 3 minus 4 over 3, so that becomes 136 over 3. Okay, so that's the answer to this question. Alright, thank you very much for watching, and I'll see you in the next video.